Hi guys, this is me back again with another interesting topic, compounds containing nitrogen. So this time we are going to deal with amines. Now as I've already written, this chapter is very easy to score. So what I have seen is this is pretty much an understandable topic and you can score very easily. So you have amines. So now in this particular section, this is under the topic of CCM, that is compounds containing nitrogen. So wherein the first section is amines, then you have cyanides, then you have isocyanides, okay, right? And then you may have something like carboxylic acid derivatives, which is better studied in the section on carbonyl compounds, okay, I mean compounds containing oxygen, like we study alcohol, phenols, ethers and everything, right? So in addition to this, you have a very simple reaction, that is reactions on nitro compounds, the preparation and all other stuff. Now let's move on to what all things you're supposed to do. Now if you could see the different questions that appear, it becomes easy if you are able to understand certain set of reactions. So reactions of amine using nitrous acid. So you might be knowing primary amine gives an alcohol, and that's aliphatic primary amine. Aromatic primary amines would give diazonium salt that could undergo a series of reactions. So you have a separate section on that. 2-degree amines are going to give you a nitroso compound, and basically there is no specific observation when you have a 3-degree amine. Then you have degradation reactions, that is Hofmann degradation reaction, which reduces the number of carbon atom by 1. Then you have certain rearrangements like Curtius rearrangement and many more. Then you have the Hofmann elimination. This is basically opposite of Saidzev rule, right? So in this case, you normally get a less substituted alkene. Okay. So this is pretty much simple to understand. Then you have chemistry of diazonium salt, one of the most easiest thing if you're able to do a lot of revision. So now let's move on to certain important questions. So if you could see, this is the first question, acetonitrile on reduction. Since this is a metal, this has to be reduction. Okay, so now this acetonitrile on reduction would give you an amine. So it's going to be something like CH2, NH2, right? CH2, NH2, and this is an R group which is CH3. So if you could see here, using nitrous acid, this NH2 converts to OH, right? So this is nothing but a 1-degree alcohol. 1-degree alcohol on treatment with K2Cr2O7 would give an aldehyde which is not isolated, but you have an acid which is isolated. So the correct answer to this particular question is acid. Again, this is pretty much easy. Now let's move on to the next part. So if you could see here, identify the product Z in the following reaction. So you have aniline, acetylation gives X, then bromination in presence of a solvent, and then you have hydrolysis. So here is a very simple logic. So let's talk about this particular reaction. Okay, so now let's say if you have NH2. So I'm just going to write NHH. Now instead of using acetyl chloride, I'm going to use instead of using acetic anhydride, I'm going to use acetyl chloride. So the reaction is going to be the same. So I'm just going to write it this way. So you'll have COCH3. Okay. So now basically what happens, HNCl would go in the form of HCl and you'll be getting NH. Okay. So you will be getting NH. Then you have C double bond O. Then you have CH3. Okay, so this is easy. So now once you do the hydrolysis, what happens over here? H comes here, OH comes here. So if you could see, the NH2 group is going to be regenerated here. So again, if you could see here, there is acetylation and there is hydrolysis together. So that means the compound Z has to contain an NH2 group. So if you carefully look, the only possibility over here is aniline, right? Acetophenone not possible. Acetanilide is NHCOCH3, parabromacetophenone. So this is practically the answer. So by a completely different approach, you could solve this particular question. Now, if I have to solve this, aniline would get acetylated and then bromination would happen at the para position because ortho position is blocked. Now let's move on to the next part, aniline. So if you could see this is nothing but diazotization, right? So you get a diazonium salt, and then if you could see cyanide, this is a nucleophile. So it's going to be something like C6H5, okay, C6H5Cn. Now, if you could see here, this is acid catalyzed hydrolysis, right? So cyanides on hydrolysis will give you carboxylic acid. So again, it's very simple to understand that B is the answer for this particular question. Okay, now let's move on to this particular question, intramolecular reductive amination. Now that means, first of all, the reduction is happening, right? And amination. Now let's see what exactly is going to happen. So the reduction is supposed to happen over here. So this particular fragment would become like OH. Okay, so now let's try to rewrite this. So it's going to be something like a cyclohexane rings connected to an OH group. Okay, so now this is, I'm just going to number this. This is number 1, number 2, number 3. Okay, so now this is connected to number 1. Okay, 1 is connected to a methyl group, and then 1 is connected to 2, right? And 2 is connected to 3, and now this 3 is connected to NH2. So I can write this as NHH. So if you could see here, H2 and O will, H and OH would go in the form of H2O. So if you could see here, the possibility is this particular product. Okay, so it's going to be something like, so if you could see, this is number 1 carbon, number 2 carbon, number 3 carbon, which is connected to nitrogen. Okay, so the answer to this particular question is option C. Now, major alkene in the following reaction. Okay, so this is basically Hofmann elimination. So again, as I said, in this case, you get a less substituted alkene. Okay, so there are 2 ways wherein you could do this. Having a look over here, it's very much clear that this is going to be the answer, because this is the only less substituted alkene. But you have to be very careful, because there could be a lot of distractors in these type of questions. So try to count the number of carbon atoms, 1, 2, 3 and 4. Again, you have 4 carbon atoms over here. Again, these 2 are actually out, and this is not done as well. So you have C, 1, 2, so 3 carbon, and then you have 4 carbon, 6 carbon. This is not possible. Okay, again you have 1, 2, 3, 4. This may be possible, right? But again, if you could see, there is no branching over here. So the possible answer is B. Now let's see how exactly do you get that. So I'm just going to write CH3. Okay, and then now this is connected to CH. Okay, so now I'm going to write this as CH this way. Correct, and then you have N. Okay, so you have N, and there is a methyl group, one more methyl group. Correct. So NCH3, and then you will be having something like this. So you have CH2, CH3. Okay, and as usual, this is a quaternary ammonium hydroxide. So I'm just going to put a positive charge over here, and I'm just going to write OH minus over here. Okay, so instead of writing CH3, I'm going to write this as CH2H. Okay, so if you could see here, this is beta elimination. So this is alpha carbon, this is beta carbon. Okay, and again, this is beta, beta dash. Okay, so if you could see, if I remove this hydrogen, this is going to be more hindered. Okay, this is going to be more hindered. So the only choice which I'm left is to remove this hydrogen. So the moment OH minus attacks this less hindered hydrogen, so the bond shifts over here, nitrogen gets the lone pair back, and then that's how you will be getting something like this. CH2, okay, double bond CH, and then you have CH2, okay, and you have a CH3. Yes, so basically this is the answer. Again, very, very simple to understand. Okay, so if you could see here again, this is Hofmann elimination reaction. So now let's see what exactly has happened over here. So let me directly write it here itself. So now when you do the alkylation, so it's going to be something like this. CH3 is going to come here, right? And then positive charge would be here, and this is nothing but reaction with AgOH, moist silver oxide. Okay. So that means I'm going to have something like this. So you have a group like this, correct? This is connected to N. This is connected to a methyl group, okay? And now I have another ring, okay? And then I have one ring this way, correct? So, and then I'm just going to write here OH, minus. Okay, so there is a positive charge over here, so this is the alpha carbon, okay, and this is the beta carbon. So these two rings are similar, no need to bother about this. Now this is the alpha and this is the beta. Okay, so if you could see, all the ring sizes are same, correct? So beta, so where exactly what exactly is going to happen over here? So there is a hydrogen over here, OH minus will be attacking here, so the bond shifts here, nitrogen gets the lone pair. So the only choice which is left is, now this particular fragment is intact, so I'll be having something like this. Okay, so I'll be having something like this, and then this bond has already broken, right? So now if I'm going to number, this is 1 is connected to 2, 2 is connected to 3, right? So this particular ring has ruptured. So now 1 is connected to 2, okay, correct, and 2 is connected to 3, and if you could see between 2 and 3 there is a double bond. Okay, so the only possible answer over here is this one, and even otherwise if you could look, the only possible less substituted alkene is this option. Okay, so this is about the Hofmann elimination reaction. Okay, so now these are the ring expansion reactions. If you could carefully work out with the mechanism, and obviously if you could see here, this is nothing but a Beckmann rearrangement. Okay, so in case if you are not able to solve it, just try to understand that H2 and O is going to make a hydroxide, an oxide, not a hydroxide but an oxide. So whenever the rearrangement happens, atoms are not eliminated, right? Only the skeletal rearrangement is going to be happening over here. So it's an obvious thing that it should contain a cyclic chain and nitrogen as well. So the only possible option over here is option C. So if you could refer something called as Beckmann rearrangement, okay, Beckmann rearrangement, then you will be able to solve this. This is pretty much simple to understand. Maybe I may have a video on Beckmann rearrangement in the upcoming days. So this was about certain important questions on the section on compounds containing nitrogen. Thank you. I hope you have enjoyed learning the nitrogen section, that is amine section of this particular topic. For more updates, please stay tuned for the upcoming videos.